Hello everyone and welcome to Physical Science Unit 8 Section 4. Today we're going to talk about power and who is more powerful and what powerful actually means. So, am I more powerful than you? I don't know. We'll see. Okay, so here we have an image and I want you to think, who is doing more work? So we got an image of a girl going fast to class because they're all late, and she's like really hustling up these stairs. She's going fast, and these two are just like, I'm late again, whatever. Who is doing more work? You may initially say, well, obviously the girl going fast is doing more work because she's going faster. What if I were to tell you they were actually doing the same amount of work? Yep. They're still traveling the same distance and going against the same force. They're doing the same amount of work. But you may wonder, well, but she's going faster, so she must be doing more work. No. She is actually more powerful. They are doing the same amount of work. They are going up the same staircase. They are going against the same forces. But she would be more powerful because she's doing it faster. So let's get a definition of power. Power is the amount of work done in 1 second. Okay. So it's the amount of work you do over a given time. Power equals work over time. In our previous image, both of them were doing the same amount of work, but their time was different. One was faster than the other. So the one that was going faster was more powerful. The unit for these is going to be watts or kilowatts. We will mostly be working with watts. So let's turn this into our triangle like we do with everything. And work is on top of a fraction, so where do I put it on the triangle? I put it on the top. Time is under it, so where do I put it? Below work. And then what is left over, you just shove in. So anything over here, you just shove into whatever hole is left. So we have power equals work over time. So let's go through an example. How long will it take a runner to do 1,000 joules of work if the power is 125 watts? Let me write down my unit so I don't have to keep reading this because I don't like reading word problems because I think it's tedious. So 1,000 joules. I have to think, okay, well, what is that? Joules is a unit of work, so 1,000 joules of work. So work equals 1,000 joules. And it says his power is 125 watts. And it says how long will it take? So what am I really solving for if I'm talking about how long? I'm solving for time. So if I plug it into my triangle, which is power equals work over time, power equals work over time. My work has to go on top. My power went over here, and I don't know what my time is. So when I do that math, I end up with 8, because 1,000 divided by, remember that line of 1 over the other, 1,000 divided by 125 is 8. So my time is 8. Well, what unit is time normally measured in these problems? Well, power is the amount of work done in a second. So seconds is my units. So how long will it take a runner to do 1,000 joules of work? If their power is 125, it would take them 8 seconds to do that much work. All right, second one. This one makes it a little more complicated, and that's why I put up, remember, work equals force times distance. So let's see. It says the book moves 4 meters. Meters is a measure of distance, because meters is length, with 5 newtons of force. My force is 5 newtons. Notice I'm writing down everything I work with as I go, so I don't have to keep going back. It takes 2 seconds. My time is 2 seconds, because time is measured in seconds, to move the book. Calculate the power. So I'm trying to solve for power. and I see my variables, and then I go back to my triangle. I have distance, force, and time. Oh crud. I have time. I'm solving for power, but I don't have my work. What do I do? So I go back to my problem. I have time. I have these two numbers, but I have time and I have these two numbers, but I don't have work. How am I going to get work? I said remember equals force. Work equals force times distance. So my work equals my force times my distance. Turning that into a triangle, force times distance, that means F and D need to go on the bottom, equals work. So I need to plug these two numbers in. So for distance, I need to plug in, and write it down. I need to write in 4 meters. For my force, I have 5 newtons. So I'm going to replace my force with 5 newtons. Well, 5 times 4, give me my work, equals 20. And why do I know multiply? Because they're side by side. I'm solving for work. Then I take work equals 20. Now can I use my other triangle, which says that power equals work over time. And I'm solving for power. So I can plug in my numbers now. For my work, I just calculated it as 20. And my time, they gave me in the problem, which was 2. So 20 divided by 2 equals 10. And then I think, okay, well, what is power measured in? And I have the units memorized, and it is in watts. So it would be 10 watts. Okay, true story. My cousin's child, he named Watts. So I always make jokes about how powerful Watts is. I actually even made Watts a cape with the triangle for power equals work over time. And good thing my cousin has a good sense of humor, because I'm always like, kilowatts! So yeah, Watts is very powerful, even though he's very small. Okay, everyone, have a great day! But yeah, my cousin's kid's name is really, it really is Watts.